Hello, I'm MolzahnShillingstad.
And I'm Alexander Molzahn.
And thank you for having us on this TED Talk today. Today we're going to be talking about nitro compounds, and without any further delay, we're going to get started. So first up is black powder, the really first explosive.
So what was black powder? Black powder was the first explosive ever made. It was used in the early centuries in China, Arabia, and India. And early Chinese texts referred to it as the fire chemical or fire drug.
Ingredients in black powder. We really don't see any recorded list until about 1000 AD. Then we don't see any ones really that have the proportions until about 1260, and the Europeans couldn't capitalize on the list they had because they were written in code, and they didn't even crack that till 1910. The formula for black powder is pretty easy. You could make it in your kitchen if you really wanted to. So it is 7 parts nitrate salt, which is KNO3, 5 parts sulfur, and 5 parts carbon. Generally people use like powdered charcoal because it's easy and safe to work with.
So the reaction. The reactants for black powder are all solids until heat is induced. Once heat is induced, 8 molecules of gases are formed, and these hot expanding gases propel a projectile. And what happens with the solid products, they're dispersed as tiny molecules, which give you like the dense black smoke that you get when you shoot black powder.
What would black powder have been used for? So they really didn't use it to play pranks on their friends by throwing firecrackers at them. They would use it in religious ceremonies and also for intimidation during a war. Then, right around 1000 AD, you start seeing it used in a weaponized form through the devastating Chinese fire arrows. And then, around 1300, 1325, then we start to see the use that we commonly see today, which is guns. The first one was the firelock, which is essentially an iron tube, and you would pour everything in and hold it and hope it didn't blow up in your face.
And then, as this technology developed, more sophisticated firearms were made, such as the musket, the flintlock, and the wheellock. And they were used farther on through times like the Revolutionary War and the Civil War.
Yep. And so, without any further ado, we're going to go out to Alex and Kyle in the field.
Now we'll go to Alex and Kyle in the field to show a modern use of black powder. Next up is nitroglycerin.
What is nitroglycerin? Nitroglycerin is C3H5N3O9. It's a highly unstable, very explosive molecule that is way more powerful than black powder and any gunpowder used on the market today.
What was nitroglycerin used for? Well, it was used for mining purposes, building railroads, and other construction purposes.
The problem with nitroglycerin. So, we know it was highly unstable and very explosive, but this meant when it was being synthesized or when it was being transported, it was prone to explode, and the results were devastating, as it could level towns where the plants were or where it was simply just passing through. And Alfred Nobel realized something needed to change.
So Nobel's idea. Nitroglycerin is a liquid at room temperature, like this jar of Arnold Palmer, and therefore is a lot more volatile than it would be in a solid state. So Nobel hypothesized that if he could solidify nitroglycerin at room temperature, then it would be safe to transport and safer to use.
So he first started mixing it with solids like sawdust, charcoal powder, and cement, but none of these really worked.
So Nobel's solution is that he decided to try a new substance called kieselguhr, which is a naturally occurring rock that can crumble to a small, fine powder. When it's mixed with the liquid nitroglycerin, it produces a plastic, putty-like substance that can be molded in different shapes.
And Nobel called this dynamite, which a cool fact about that is it comes from
the Greek word of dynami, which means strength.
Alright, quick little fun fact. Many historians agreed that would Hannibal have had access to dynamite, he would have made it through the Alps faster and could have altered history forever. The more you know.
Up next we have war and explosives.
The new explosive. Gunpowder, while fairly powerful, left big clouds of smoke. Not good if you're trying to hide in a war. Dynamite, though, was way too powerful and would blow out the barrel on a firearm. Not very safe.
So people ask themselves what to do. Well, for small firearms like rifles and handguns, people had experimented and realized that nitrocellulose mixed with nitroglycerin worked. This mixture is what is still used today in rifles, and it's the smokeless powder that they use. And while this is great, it's still not powerful enough to shoot from a cannon.
Lay experiment. Picric acid. This was something a French came up with, and they shared it with the British. And they both used that through about World War I. But it had a reputation for misfiring when it got wet or damp, and would form picrites when it reacted with metal that exploded on impact. Not very good for armor piercing.
Next up we have TNT, which is the abbreviation for trinitrotoluene. It's a solid with a relatively low melting point. It's not acidic, and it's harder to detonate. Germany came up with this, and they used it in their munitions in World War I. And other countries started to follow them, and needless to say, TNT was booming in the early 1900s.
TNT, here's the reaction. One neat thing about it is the reason it lets off so much smoke is if you see there's 7 carbons left over, and that's why you get that big cloud of smoke with TNT.
So the downside to this was that to manufacture all these explosives, lots of ammonia was needed. During the war, the British blocked off Germany's supply for ammonia, so Germany needed to think fast on how they would get this ammonia they needed.
The Haber process. German chemist Fritz Haber solved the crisis. He figured out how to synthesize ammonia in the lab. This helped Germany to replenish their ammonia supply, which is necessary for synthesizing explosives, but also farmers, because now fertilizer was cheap and accessible to everyone. He later went on to win a Nobel Prize for this finding, where he synthesized one N2 molecule and 3 H2s under high pressure and temperatures to form an H3. And now we're going to go to Kyle and Alex in the field to show you an application of nitro powders in a rifle.
Thanks for that, Alex and Kyle.
Alright, so I'm behind the camera and we are about to go hot. Here we go. And there you have it. Okay, so we got our targets from downrange and they're done. This is just one of those things how nitro powders has really impacted us in such a huge way.